Okay. The broadcast is live. So, I was instructed to take a couple of seconds to let the stream start in full. So, I'm going to do just that before we begin. Oh, I hear myself. There we go. Okay. So, current pet peeves in C# is the name of this talk. Now, I'm not going to cover all of them. If you see my screen, you can probably more or less tell what I'm going to be talking about those things that are most commonly, that I most commonly see done badly, I guess you could say, on our server, on the C# Discord server, and also some of the things that I personally believe should have been removed from the language or obsoleted or deprecated or what have you, and yet they are still here. I guess introduction, I forgot about that. I'm Bunch of Z's from the C# Discord, as you can see in the corner here. And yeah, I'm fairly active on the server pretty much all the time that I'm online. I have Discord open somewhere in the background. So if you have any questions or something more about it, you are, of course, free to ask about that after. But let's talk about the topic of this talk, which is all those pet peeves that I have. And I'm going to be showing a couple of benchmarks, a couple of ways that it works to try to convince you that those old ways are perhaps not the best, that we have better ways of handling many things. Who pinged me on Discord? Are there any issues with something? Oh, no. Okay, it's just, doesn't matter. Okay. Now, as a preface, again, that's a long intro. As a preface, I know that C# values backwards compatibility, and that some of the things I'm talking about are still there for backwards compatibility purposes. I personally might not necessarily agree with that, but I understand where it's coming from. So it's not me bashing the language or anything of the sort. It's just showing better ways of doing things. And the first thing I notice very often, people still use web client, for example, or web request, or other various things like that. Most commonly web client and web request. Meanwhile, we have HTTP client, which is something that should be used nowadays. Here we have a simple example. We're calling an API, is even API, to check if number 87 is even or odd. If you're using like a microservice architecture, you might want to do something like that. Serializer options, it's just to ignore the case sensitivity. And as you can see, if I run this project, everything is running perfectly fine, all four of those methods, and yet each of them uses a different way of getting data from that API. Also, the response type, it's just a simple record describing the response from that API with a toString overridden, so that I don't have to do that every time. The first way, and by far probably the worst, is using web client. Now, web client is thankfully obsoleted, and it tells you that you should be using HTTP client, but people still very often use it for some godforsaken reason. Either they ignore the warnings, or perhaps they're using an IDE that doesn't give them warnings. I don't know if there are any. Maybe VS Code. I'm not entirely sure. But yeah, some people still use it. And why you should not be using it? Well, it's not asynchronous. As you can see, this getStuff web client method is not asynchronous. It doesn't return a task. That's because download string isn't asynchronous. Now we can try seeing if there are perhaps asynchronous methods of this client. And we can see that, yes, there is download string async. So why shouldn't we be using that, right? Well, that's because it's not actually asynchronous. It's doing a bunch of things. As you can see, it's void. It's of type void, not a task. This doesn't return anything. I honestly don't know what it does, how it even gives us the string. But we have also download string task async, which you might think that, oh, this one returns a task of a string, and indeed it does, but as you can see, it's not asynchronous. And the method it calls is not asynchronous either. And the method this one calls isn't asynchronous, it's void. Web client's async is fake async. It returns a task, it's technically async, but it really isn't. So you shouldn't be using that unless for, I don't know, legacy projects or something. Although HTTP client is supported in .NET ever since version framework 4.5, something thereabouts. So yeah, don't use web client. Next thing, web request. Web request create, again, it is obsoleted. And it says that you should be using all those things are obsoleted and you should be using HTTP client, but I still do see people use it. Why you shouldn't? Well, it is asynchronous, so that's good. That's already a step above web client, but there are no ways of getting things easily, so to speak. You have to go through the whole song and dance of getting the response, getting the stream from that response, creating a stream reader, reading that stream, and then only deserializing it to your chosen type. There's a lot of usings, there's a lot of awaits, like 3 usings for just a single request to an API. That's extremely simple and extremely small, and it shouldn't look that way, but it does with web request. So you can use it if you really want, but again, why? There are better ways. One such better way is of course HTTP client. We create an HTTP client. You should be reusing it. To be fair, you should create just a single HTTP client, save it somewhere in a static field, for example, or in a static public property, or use dependency injection to inject HTTP client factory, something like that. You should be injecting that. You should be just reusing it. But for the sake of this example, we're going to create a fresh one. And we can just get a string from it asynchronously and deserialize it. Just 3 lines of code. It's one less line. No, sorry. It's the same amount of lines as with web client, but we get full and proper async support. What else is cool about HTTP client? It's that we have systemnet HTTP JSON namespace available to us in .NET, and that brings that call to just 2 lines. We create the client, and we just get the JSON from it. We don't need that intermediary step of getting the string and then deserializing the string. We can just get the object straight from the API. So if being asynchronous doesn't convince you that you should be using it, then perhaps fewer lines of code will. And the same is also true for other methods. Client post as JSON async, put as JSON async, delete as from JSON async, and so on and so forth. It really, really helps us lower the amount of code. Now, behind the veil, so to speak, that get from JSON async is just getting the string and it's deserializing it under the hood. with this method. If I can get into it, read from JSON async helper, read from JSON async, read from JSON async core, serialize async helper, JSON serializer, deserialize async. There we have it. Honestly, I just kind of hate going through the .NET code at times because it's those single line methods just that abstract and abstract and abstract and abstract. But at least we're able to see what's going on here, that this is somewhere 17 layers deep in the architecture doing the same exact thing that we're doing here. We could even use the serialized async if you wanted to. So yeah, this is about the web client. The next thing, we're gonna go bottom up in my list of projects. Serialization. There are plenty of ways to serialize in C#. We're gonna be serializing a person with the name of Bob, surname Bobbit, and birthday of now. I prepared a couple of classes here. The record person, which is our base thing, serializable attribute only for the binary formatter. Then we have a separate class for XML serialization and a separate class for protobuf because it needs all those attributes. And I also wrote a couple of converters that allow us to turn that person into their respective classes, like person XML and person proto, just so you know what's going on in the code. And if we run this serialization project, we see that everything here has been serialized. And if we take a look at the file system, no, not dynamics, serialization bin. Here we see all those serialized. No, that's deps. Yeah, with JSON, serialized as JSON, serialized as protobuf, serialized as binary, and serialized to XML. So we see that all of that things, all of those methods work. They do create files as they should. But why you shouldn't really be using binary serialization? This is why. This pragma. Warning, disable syslib 0011. If we turn it off, if we delete this pragma, our project isn't even going to build because binary formatter serialization is obsolete and should not be used. And see this link for more information. Essentially, from what I gather, binary formatter gives the user, the programmer, a little bit too much control over like the raw memory almost, which isn't great because it can lead to many an issue. So you really shouldn't be doing that, essentially writing raw bytes to disk, but some people still do. And also, binary formatter is kind of takes a lot of lines, takes a lot of things to do, which is the same issue that web request had, despite being asynchronous. It just takes a lot of code. And the same goes for the binary serializer. You have to create a file stream, you have to create the binary formatter, serialize it to the stream, the data to the stream. It can throw exceptions, then you have to close it. And this deserialization is similar. You have to create the stream, you have to deserialize it. Deserialize isn't generic either. So the result of the deserialization you have to cast. Casting has a certain cost. Casting isn't guaranteed to always go well. If some bytes are off, you're not going to be able to cast it properly. And of course, it can still throw exceptions, and then you still have to close it. It's something that people still use when they think they need binary serialization. Spoiler alert, most of the time you don't need binary serialization. JSON or XML is perfectly fine, and it's perfectly enough. Unless you, for some reason, want to hide that data from the user, I guess there might be valid reasons to do that. But if the user is so inclined, they can still read that data. It's not like you're hiding it permanently. XML. C#.NET, Microsoft loves XML, so it's no surprise that we do have an XML serializer and deserializer. It is a surprise, however, just how bad it is. As you can see, we can create a new XML serializer, and we have to pass the type as an argument, as a type of the thing we need to serialize from, and then serialize to. It's not generic for some reason. Serialize method isn't generic either. And we still have to pass the file stream. And deserialization is similar. We can deserialize, again, not in a generic way. We have to cast it to our type, and then we can get the data. So this one's better. It doesn't risk, I don't know, corrupting sectors on your disk, but it just takes a lot of lines. And why, if we can just use JSON? Now, do mind, this is a little bit of an elaborate way of doing that. I'm using file stream that has to use the right async and has to be closed. You can just use the file class and make it a little bit shorter, a little bit less code, a little bit less ceremony to it. But for the sake of parity across those examples, I'm using file streams everywhere. And serializing JSON is as simple as JSON serializer serialize. You don't need to create an instance of a serializer. You don't need to cast anything. You don't need to pass types as an argument. You just say serialize and it serializes. It's that simple. Deserialization is, again, very simple. Now, this is the whole song and dance with creating a stream reader and reading from that. Normally, I would probably just do file read all text async and be done with it. But again, for the sake of parity, I'm using file stream and stream reader. Deserialization itself is as simple as calling JSON serializer deserialize and giving it a type. And that's it. You don't need to cast. You don't need to risk something not being cast properly. You don't need to create a deserializer. None of that. Just deserialize it. It's that simple. Now, some people might still want to serialize and deserialize that data from some sort of a binary format, perhaps to make it take less space on the disk or take less space over the network, or whatever other reasons you might have for it. And for that purpose, protobuf is what you should be using. Now, admittedly, protobuf is not a part of .NET. There isn't a native first-party way of dealing with protobuf. We need to use libraries. Such a library that I'm using here being protobuf.net. I don't know if it's the only one that deals with protobuf, but it's the one recommended the most. Protobuf serialization and deserialization is extremely simple using file create. Right, I'm using file create here because serializer needs a reference to the file stream, so a bit differently than the other examples. And the same goes for deserialization. It needs a file stream to deserialize. But serialization itself is a single line. And again, you don't need to pass any types as parameters. You don't need to do any casting, anything of the sort. Deserialization is, again, generic the same way JSON deserialization is. You don't need to be casting. You don't need to worry if the bytes that you read from the disk fit into the mode of this class you're trying to deserialize to. You're just doing it in a generic way. And it just works. Extremely easy, extremely simple. The only, I guess, thing that's not so great about protobuf is you need all those attributes. You need to mark this class as proto contract. You need to mark all those properties as proto members. But once you do it, you can just reuse this class. So it's it's something you do one time only, and you kind of forget about it. So if you do need binary serialization, just use protobuf instead of with binary. Next thing, parsing numbers. This is extremely common. So extremely common for people to use convert. Okay, there's no benchmarks of anything yet. I don't even know if there would be particularly much difference in performance of those methods. But we have in general, three methods of converting strings to numbers. First of them being convert. Convert to int32. If this method succeeds, then we get the number out of it. If it doesn't succeed, it throws an exception. Simple enough. Next thing we have is parse. We use type parse of the input. If it succeeds, it succeeds. If it doesn't succeed, it throws. Very simple. Then we have try parse. Try parse uses this interesting out modifier of our parameter, which means that this method returns a boolean, as you can see, that denotes the success of the parsing. If the parsing was successful, it returns true. If the parsing was not successful, it returns false. And then it puts the value, kind of pushes it out into this variable. Now this joins the passing of the value with the variable with the declaration of it, but you could just do int x, and instead of out var, you could just out x. That also works. But I usually prefer just doing this out var num. And of course, if it succeeds, so if it's true, then we get the number. If it fails, then it returns an information that it is not a number. Now, what else is different between them? Because so far it would seem that the only difference is that this returns the result of parsing, and those two throw instead. So not particularly much difference between them. Well, there is one more difference, and the rest of this code will help us figure this difference out. We will be deserializing. We will be parsing or converting all those different values to numbers, to integers. String of 0, null, string of 179, and the word kookaburra. And this will help us with it. It's just an array of the methods that we're going to be using for parsing, color to show up in the console, and the name of this method and the method itself. Then we for each over this array, and on every element of this array, we call the function, we call the method, and we see what the output is. And you will see the difference as soon as we run this project. And there we have it. Convert. For 0, it returns 0. For null, it returns 0. For 179, it's correct because it prints out twice the value, so 358. And for kookaburra, it throws an exception. Expected. Not necessarily, because null and 0 are two different values, and yet both of them are converted to a 0. You'd think that null is just not a number, so it should be throwing or doing something, but not convert. Convert treats a null as 0, and it can lead to many an issue that you could avoid if you were to just use parsing, because int parse or double parse, float parse, decimal parse, etc. on null will throw an exception, which is something you want. Except exceptions have a certain inherent cost to them. The cost of creating that exception, then disposing of it. exceptions are disposed. But yeah, the cost of creating that exception, then the garbage collector has to collect it. And yeah, and besides that, the syntax of try catching is, in my opinion, a little bit less friendly than just an if else. If else is easy, if else is simple, if else is one of the first things we learned in any language, so it makes sense to make things simple. And int tryparse allows us to do that. As you could see in the code above, it doesn't throw anywhere. Instead, if it can parse the number, it will parse it. If it cannot parse the number, it will just go into the else, and it will just return not a number. Very easy, very simple. Use tryparse. Please use tryparse. It's, as you can see, very easy, very simple, and allows us to avoid a whole slew of issues. Next thing, I'm kind of running out of time, but it's the last talk, so I hope you forgive me if I dig into the 5 minutes of the Q&A session or something. Dynamics, mostly in the context of serialization and deserialization. I have here a simple benchmark that benchmarks serialization and benchmarks deserialization of this JSON string. Here we have a Bob who's 43, he's forklift certified, and lives on Daisy Boulevard 23. And we have many ways of deserializing. Deserializing or serializing? I'm getting lost. Deserializing it to a class. Class person, class address. Very simple things. Nothing fancy going on here. And we have multiple ways of doing that. People sometimes deserialize to dynamic. And I spent a lot of time trying to figure out how to make it work even. So I have a certain amount of respect to people who consciously choose to deserialize to dynamic, because how are you willing to deal with this? I wouldn't. I don't have the mental fortitude. But if you do, hell, all the powers to you. Why is that an issue? We deserialize to dynamic, and we get a dynamic. But that dynamic, under the hood, is really JSON element. So we are bound to start deserializing all of that stuff based on that JSON element. And dynamic isn't an any. It's not an object. It's not a whatever value. It doesn't get rid of type safety. It creates the types on runtime. Or rather, it assigns the types of runtime. It's like var. It's like type inference, kind of, sorta, but during runtime instead of compile time. So you lose a fair bit of performance, and we're going to take a look at that. We get the JSON element out of it, or rather, we have to cast it. Then to get the name, we need to use the tryget property. Tryget property. Address is also a property, so tryget property. From that address, tryget property street, tryget property number, and then we get all those results of trying to get those things, and we get the return from it. You're already familiar with this syntax because it's the same with tryparse. In general, the try pattern has very similar syntax everywhere, be it tryget value on a dictionary or tryget property on a JSON element or whatever. We have to check all of those. If any of them is false, that's why you don't do that. And in the other case, we need to take those properties, and they are still untyped. They are all still JSON element. It doesn't get parsed to integers or strings or what have you. It gets parsed to JSON elements. So then from those JSON elements, we have to get the string, get the Boolean, get the string, and get the integer 32. It's a lot. If you want to handle dynamic deserialization properly, this is the amount of code you will have to write. If you don't want to handle it properly, I guess you could do it maybe easier, but I honestly can't see the way. I was trying, when writing this code, I was trying to do various things, like, for example, trying to refer to person name directly. Yeah, let's just get rid of the error. But yeah, I was trying to do that, but then I was getting errors that name doesn't exist on JSON element, and it was a pain. It was a huge pain, but I made it work for benchmark purposes. Then another way I see dictionary string object, for example. It's a very popular and common pattern in Dart. I noticed if someone was using Flutter and communicating with some API, then Dart recommends that you deserialize your things, your JSON, to dictionary string dynamic. Beats me. Dart supports generics, but for some reason doesn't support generic deserialization. I don't know. Whatever, we're talking about C# here. And this is slightly better, very slightly better. Because from this person, we can get our properties, our name, and our forklift certified as things from the dictionary. Although, as you can see, not entirely. Because whatever you get from here will still be a JSON element. On the runtime, those objects are all JSON elements. So you still have to, in this case, cast it to JSON element from an object, and then use getBoolean anyway. And of course, from address, since it's nested, you can't refer to it as address and then something. Address, because it's not a dictionary, it's JSON element. So those objects, as I mentioned, they aren't dictionaries of string object, and further, there aren't dictionaries of string object. They're all JSON element. So we have to use the pattern of try get property, and then, of course, get string, get int, the whole song and dance. So again, my question is why? Why would you subject yourself to that? If you can just create a class person, class address, and do this. Single line of code takes care of everything. There's no need for any song and dance. There's no need for 15 lines of code just to get the values. You just deserialize it into what you need. Yes, you need to create the classes, sure, but there are ways to deal with that. For example, I can copy this and use edit, paste special JSON as classes, and this just creates a class for me that okay, maybe not the best. No, not the best example. Edit, paste special JSON as classes, and it just creates those classes for me. I don't need to write a single line of code. It gets generated. There are online tools that allow you to do the same thing. Visual Studio also has edit, paste special JSON as classes. So just create those classes. I beg of you. Save yourself some time. Save yourself some time and performance. Let's get to the benchmark part. Dynamic takes 2.27 microseconds and allocates 736 bytes. Dictionary takes 3 microseconds and allocates 1500 bytes. And class is the fastest of them all. 1.5 microseconds. It allocates slightly more than dynamic, but only slightly. So you have to ask yourself, is it worth it for the benefit you get in the sense that you have less lines of code to take care of? You can write code more type safe. You don't need any magic strings like you have in all those cases, like in the case of the dictionary or the dynamic, right? All of those are magic strings. All of those are prone to typos. So do you really want to subject yourself to that to save 100 bytes of allocations? I wouldn't. especially since you also get a boost in performance. So again, please, just serialize and deserialize to proper classes. There's no need to do anything else. And the last thing on my list, the one that probably annoys me the most, the one that definitely annoys me the most, collections. Program, this just runs the benchmarks. I'm not going to run those benchmarks live because they take a lot of time and completely lock out my PC. And it's not like super great PC, but it's Ryzen 5 1600, so it's not that bad. But yeah, it's just simple thing about collections. We have a collection filled with random values. First, let's start with ArrayList versus generic list. ArrayList, we're benchmarking adding to that list. Very simple. We generate a value, we add it to the list. Easy. Same for the generic list. Generic list. Adding, generic list. Reading, we for each over the whole generated list. We take the values, we do some very simple math on them, and we return the result of that math. And the same exact thing we're doing with ArrayList. We're adding to it and we're reading from it. The one difference you notice is that this line here isn't necessary because it's just a temporary variable. I and the num are both integers, so this whole num isn't needed. But again, for the sake of parity, it's here because it's needed for reading from ArrayList. Because ArrayList is a list of objects, essentially, under the hood. It is a list of objects, so you have to cast everything to an integer. And all those values are boxed because they are stored as objects, not as integers. And the benchmark runs for 1,000 values and for 10 million values, just to have a little bit of a spread. And as you can see, the results are, well, they speak for themselves. Where generic list takes 13 microseconds, 4 microseconds for reading, 13 microseconds for writing. ArrayList takes 22 microseconds for writing and 12 microseconds for reading, 3 times the time it takes for the list. That's because of the casting, that's because of the boxing. You can see some allocations happening. Generic list allocates, allocations here. Generic list allocates 8,000 bytes for writing, nothing for reading. ArrayList allocates 40,000 bytes for writing and 48 bytes for reading. And that's just for 1,000 elements. For 10 million elements, we again see almost, 4 or 5 times more time. This takes twice as much time, and we again have some serious allocations, almost 5 times the amount, 4 times the amount of allocations of memory allocated. And here we have, what's it gonna be? 6 times the allocation, something like that. So from the performance perspective, just don't. Both from the performance perspective and from the perspective of having to cast it, why would you need to cast it if you can just store those values directly? The other thing, generic, non-generic, is HashTable versus dictionary t-key, t-value. Again, very similar benchmark. We're adding some values at key equal to the position in the dictionary. Reading, again, very simple. We're reading a certain value from it. The same goes for a hash table. We're adding and we are reading from it. Although, as you can see, it needs to be cast, and we need this null something operator. Forgot the name of it. Because the result of it can be null, because HashTable and ArrayList store object with a question mark. Nullable objects. So it can be null. If it's null, we need to provide a fallback and then cast it to an integer. And it's again that little bit added mental overhead that you have to keep track of it, you have to worry about it, and a little bit, a fair bit actually, of performance overhead. Twice the amount of time that it takes, twice the amount of time. Here we have like 3 or 4 times the amount of time, twice the amount of time, just because we're using non-generic collections. And let's look at allocations. Orders of magnitude more allocations, 0 allocations versus 24,000 bytes, orders of magnitude, and this is just a lot of allocations. So don't use those do use generic collections. Don't use the non-generic ones, both from the standpoint of performance and from the standpoint of just having less things to worry about. Just use generics. Now, also, a bit of a plea to Microsoft employees. Could you just mark those non-generic collections as obsolete or deprecated or something? Because there's nothing like that on them. When I get into the hash table, I'm not even sure if it has any attributes on it. Debugger type proxy, debugger display serializable. Yeah, it's not in any way, shape, or form deprecated or anything. People shouldn't be using them because there's no need to, but they use it because they don't know better. And also because some of them might be coming from Java, where our list T is Java's array list, essentially. So the names are similar and they can get mistaken. Now, I understand why HashTable and ArrayList are still a part of the language. They were collections in the language before generics. If I'm not mistaken, I'm not hugely into the .NET history, but Microsoft kind of wanted to push .NET at a certain time, and generics weren't done yet, but you needed collections, so they added non-generic collections. When the generics were added to the language, then they added the generic collections, but the non-generic collections just stayed there, and honestly kind of overstayed their welcome. In my opinion, it's high time to just get rid of them. Cartago delendam est, or non-generic collections delendam est, or however you say it. And that about concludes it. I already went way over my allocated time. Yeah, so hopefully it's not a problem. But yeah, that's gonna be it for now. Now I'm gonna take some questions from the chat, if there are any. I have a bit of time, so we can use it. Let's see. Questions. Where do they start? Let me scroll here. Okay. I think I found the beginning of the questions. Someone's asking about what IDE it is. It's Rider. It is Rider. It just uses the Monokai theme, so the theme is a little bit different. What else do we have? Talking about JSON in the context of an obsolete API talk, is there any reason to use Newtonsoft anymore now that system text JSON is a solid native option? Can it still do some things system text JSON cannot? That's a good question that I don't really have a good answer to. Up until not that long ago, Newtonsoft did support some things that STJ didn't. For example, traversing the JSON tree as a collection of nodes. Now system text JSON does support it. Does it have any other differences in feature parity? I'm not sure. I'm gonna say that for like 99% of cases, there's no reason to use newtons of JSON. System text JSON is enough. If you do have some case that system text JSON doesn't cover, if you're working with some completely bonkers unstructured data, sometimes happens, some APIs are really, really bad, then perhaps Newtonsoft will have some tools that will allow you to deal with that better, although it's most on a case-by-case basis in my experience. So you're going to have to look into that yourself. Next. Did you consider discussing data contract serializer and friends? I have no experience with them, so I didn't consider discussing those. I wanted to talk about the things that I'm somewhat confident in talking about, and yeah, I'm not familiar with data contract serializer. Same reason that someone asked me about data tables, I think. They are also something that's obsolete, and am I going to talk about them or not? Again, I have no experience with them, so I'm not going to talk about them. Let's see. Message pack. Faster, can be contractful, contactless, full IoT friendly, Unity, but I'm sure you'd need more work for other language to receive binary data and deserialize it. I'm not familiar with message pack, or rather, I know what it is, but I haven't worked with it. And there's also a good question of other languages being able to receive that data. JSON is universal, XML is universal, protobuf is also universal. So those are the things that you should be using, and any other language mostly will be able to make heads or tails of them. Let's see, what's next? No, those are repeats. What keyboard do I have? This keyboard is a GMMK, the first one, GMMK with, I think, Gatron blue switches. So that's probably the sound you've been hearing. Gatron blues. A bit clicky, but I like the sound. Is there anything you think Microsoft can do to make people more aware of not using obsolete stuff like web client? Honestly, it's already marked as obsolete, so if someone is using it, then that's on them. The only thing that could be done, step above, would be completely marking it as deprecated in the same way that binary formatter is, so that it just doesn't compile if you use them, and the step above that would be just removing them from the language. Although, as evidenced by non-generic collections, Microsoft is kind of apprehensive from removing anything from the language, unfortunately or fortunately. Have you considered writing a class deserializer to dynamic and use a name of to all member name to get the name type? I don't think I did. I don't think I did. I was kind of just, at one point, just bashing my head onto the keyboard, trying to figure out how to get it to work. Because I was told that, hey, dynamic is the easiest way to do that. Why would I ever need to write classes? Turns out, no, dynamic isn't the easiest way to do that. It's anything but. If you could outright delete a single class method in the core library, what would it be? Non-generic collections. Delete the whole thing, burn it to the ground. It's not needed, it's not necessary. And quite frankly, the concern is that there are some old projects that still use it, so we shouldn't break backwards compatibility. If there's a project that still uses non-generic collections, chances are they haven't migrated past .NET Framework 3. They're not going to be bothered by those collections being removed in .NET 8. So we should just rip off the band-aid and let it rip and just delete it. Cartago delendam est, essentially. Okay. Data contract serializer. No, that's not a question. How did you discover the best practices you demonstrated? Was it trial and error where you taught, or did you stumble on better ways to manage JSON through your own investigation? Kind of a mixture. Kind of a mixture of those. The best practices. Yeah, trial and error. I don't think it was trial and error, unless in the context of this project in particular. Right from the get-go, back when STJ wasn't a thing, I was using Newtonsoft. I wasn't trying to do anything with like dynamics and whatnot. I didn't even know dynamic existed back then. Since STJ, I've been using STJ, and that's about it. That they told me that's the thing you should use. Microsoft said, hey, we have that cool new API of dealing with JSONs. And I'm like, all right, I'm going to start using it. And I just started. When it comes to this project, dealing with the dynamic and all of that, a lot of trial and error indeed, and a lot of Googling, a lot of like 2013 posts from Stack Overflow with people having those issues and stuff like that. It wasn't fun. I mean, it was fun, the investigation part. It wasn't fun having to deal with all of that. What else? How do you feel about Unity and similar engines using outdated frameworks, basically forcing new developers to learn all the deprecated classes since the new ones aren't available? I don't feel good about it. How would I? It's those engines should be getting on with the times, and some newer engines do. I know that Godot in version 4 is going to switch to .NET 6, if I'm not mistaken. I know Stride is also more or less keeping up with the .NET versions. It's just Unity that's an outlier. But it's also kind of understandable in case of Unity. They're using some very customized things. They have all that like custom compiler that compiles C# to C++. It's called Burst. I don't know. I'm not sure. But yeah, they have all those custom tailored things. So migrating from that, from somehow, trying to get Mono to work everywhere, migrating that to .NET, it's going to take some time. So I'm willing to excuse that. I didn't see Pet Peeves on result or wait. You're actually right. You're actually right about that. I should have added that, but I wouldn't be able to fit it into the time I had allotted. Even now, I wasn't able to fit it all. But yeah, don't use result. Don't use wait. Just await it. If it's asynchronous, just await it. Please. You're going to thank me later. And that seems to be it. That seems to be all the questions on the Discord server. Unless you have any more, then I still have a little while. Okay. Thank you for having me then. If there are no more questions, then I think we can end it. I'm still going to be hanging around in the chat. So if you want to talk about something else, then I'm going to go back read a little bit about what you were talking about all this time. And I'm going to stick around to answer some questions if you were to have any more. But I see several people are talking, so... Okay, yeah. Thanks for having me then. You can, I guess, end the stream. I can do that on my side. So I'm going to wait for that to happen.